Good morning. It is Thursday, May 7th. This is the third and final lesson, the fifth day I think we've been working on this, the sinusoidal models. I just want to go over a couple more with you. And again, sinusoidal models, just like sinusoidal graphs, we're going to be using amp, sin, freq, x, shift. And for these models, I really want you to draw a little picture, because drawing that little picture will help you stay very structured, which is really, I think, the most important thing you can do. So let's see, we did this one. We got another Ferris wheel one. Let's do a Ferris wheel one, and let's do the tides one. And then we're going to call it a day. So let me just create a little more space here. A high roller, a Ferris wheel in Las Vegas. Opened in March 2014. The 550 feet tall wheel has a diameter of 5 to 20 feet. So, if I'm making my little picture, it's 500 feet tall. That means the max is 550. It says the diameter is 520. If the diameter is 520, the distance from the max to the min is 520. So my minimum value is going to be 550 minus 520, which is 30. The diameter of the wheel is the distance from the max to the min. So I can subtract my diameter from the max to find my min. Now that I have my max and my min, I can find my midline. My midline is min plus max over 2, which is 30 plus 550 over 2, which is 580 over 2, which is 290. So my midline, I'm just going to put it over here, it's getting a little messy. My midline is 290, my min is 30, my max is 550. All right, a ride on one of its 28 passenger cars lasts 30 minutes. The time it takes the wheel to complete one full rotation. The time it takes the wheel to complete one full rotation. By definition, that's the period. It's saying that the period is 30. The period is the time it takes the wheel or the function to complete one full cycle at the time it takes the wheel to make one full rotation. Assume that once the wheel is in motion, it maintains a constant speed for the 30-minute ride. Sketch a graph of the height of a passenger car on the high roller as a function of the time the ride began. Well, where's the ride beginning? A ride on one of its... So, oh, here we go. Riders board the passenger cars at the bottom of the wheel. So it's starting at the bottom. If it's starting at the bottom, it's got to be a negative cosine. So I'm going to draw in the rest of my negative cosine, and there it is. So, sketch a graph, write a function. Let's get this information onto a new page. So let me snip this thing. And let's go to my graph. It's a giant graph. Let's make it a little bit smaller. Oh my god. So big I can't even deal with it. Alright. So, I've got to go up to 550, so making each box worth 1 is definitely not going to work. We did this earlier in the year. You could always do the max divided by the number of boxes. So 550 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Again, you could just kind of try random values, but I taught you this earlier in the year. It's 32 point something, so I want to make it something bigger than that. Easy to work with. I'm going to go by 40s. So I'm going to go 80, whoops, 80, 160, 240, 320, 400, 480, 560, and that's high enough. So my midline is 290, so that's going to be in here. My max is 550, and my min is 30. It wants me to graph the height of the passenger car, so it's a negative cosine. So let's get a different color in here. So it's going to start at the min, then it's going to, oh, it's going to be 4 dashes. 1, 2, 3, 4. The period goes at the end of the 4th dash. Negative cosine is min, midline, max, midline, min. And there it is. It wants an equation. So for the equation, I need an amp. Amp is the distance from the midline to the max, or the midline to the min. That's 260. It's a negative cosine. Frequency is 2 pi over the period, so 2 pi over 30 reduces to pi over 15. And the shift is your midline, which is 290. If it's asking for anything fancy, it says H and T. So H equals negative 260 cosine pi over 15t plus 290. It said to identify the amplitude, midline, frequency, and period, and explain how they relate to the situation. I'm not going to write that out. I'll explain it. The amplitude is how high you're going from the midpoint, from the average. The midline is the average height. The frequency is how many times you go around between 0 and 2 pi, which doesn't really make much sense in the context of this question. And the period is how long it takes to make one complete rotation. If you are on this ride, how high would you be above the ground after 22.5 minutes? Well, for that, we're going to have to cut this in 4. 30 divided by 4 is 7.5. So that means that this is 7.5, another 7.5 is 15, another 7.5 is 22.5, and another 7.5 gets me to 30. So again, if I'm graphing something, I don't need to fill in everything, but it's possible they might ask you a question where you may need to, like here, to get how much each dash is, I'm dividing the period by 4. So what's the height? The height is at the midline, which is 290 feet. These are not simple questions. I don't think it's really impossible as long as we understand all the little components to it, but definitely not a simple lesson. I went over each thing. Again, drawing a little picture is very helpful in helping you stay organized. And if you have a Ferris wheel question, the diameter is the distance from the max to the min. So let's go over one more. Let's get this on a different page. Let's also get this follow-up question on a separate page. The ocean tides near Carter Beach follow a repeating pattern over time. With the amount of time between each low and high tide remaining relatively constant. On a certain day, low tide occurred at 8:30 a.m. and high tide occurred at 3 p.m. So if I glance down, T is hours since 8:30 a.m. So 8:30 a.m. is where this thing is starting. It's starting at low tide. So it's starting at the bottom, which means it's got to be a negative cosine. Now, its low tide is 8:30, and its high tide is 3 o'clock. So how many hours after 8:30 is 3 o'clock? Well, it's 1 hour would be 11:30, sorry, 9:30, 2 hours would be 10:30, 3 hours would be 11:30, 4 hours would be 12:30, 5 hours is 1:30, 6 hours is 2:30, 6.5. So this is going to be time 6.5. And since that's half of the wave, it's going to take 6.5 more hours to get to the end of the wave. So my period is going to be 13. High tide was 12 inches above sea level. So my high tide is 12. Low tide was 12 inches below. So low tide is going to be negative 12. So my midline is min plus max over 2, which is negative 12 plus 12 over 2, which is 0 over 2, which is 0. Min equals 0. Again, some of you are wondering where the 13 and the 6.5 came from. I counted out from 8:30 to 3 is 6.5 hours. So I've got my little picture. It wants me to write a function. All right, well, amp sine freq x shift, amp sine freq x shift, amp sine freq x shift. Amp is the distance from the max to the midline. My amp is 12. It's a negative cosine. Frequency is 2 pi over the period, which is 13. Shift is the midline, which is 0. So f of t is asking for f of t equals negative 12 cosine 2 pi over 13t. There's no shift. There it is. On the grid below, graph one cycle this function. So I'm going to take my little picture with me because that's very important in helping me. Control C, Control V. Can I go by ones? I don't think so because there aren't enough boxes, so I'm going to go by twos. Let's just make it smaller so everything fits. So I'm going to go by 2. So this is going to be 4, 8, 12, -4, -8, -12. Midline is 0. Max and min. 4 dashes. 1, 2, 3, 4. Period at the end of the 4th dash. Let's get a different color. Starts at the min. Midline. Max. Midline. Min. And there's your wave. Now, there's another follow-up question. People who fish in Carter Beach know that a certain species of fish is most plentiful when the water level is increasing. We talked at the beginning of the year about what increasing means. Increasing is when the function is going up. So this purple piece right here is where it's increasing, and we'll make the yellow where it's decreasing. So my purple is where it's increasing, my yellow is where it's decreasing. We talked about that earlier in the year. Explain whether you would recommend fishing for this species at 7:30 p.m. or 10:30 p.m. using evidence from the given context. So, first of all, I want to convert this into hours after 8:30 because on my graph, T is hours after 8:30. So how many hours after 8:30 a.m. is 7:30 p.m.? Well, 8:30 p.m. would be 12 hours. It's 1 hour less than that. 10:30 p.m. is 3 hours later. That would be 14. So we're taking a look at time 11 and time 14. So time 11 would fall somewhere around here. Are we increasing or decreasing at that point? Well, at time 11, it's decreasing. So we want to go when it's increasing. 7:30 is a bad idea. Now, I don't see time 14 on my graph, but I know how a wave works. I'm going to start repeating another cycle. So if I were to keep on going, my next point is going to be here, and it's going to continue up like that. 14 is somewhere around here, and here, yes, it is increasing. Let's make it purple, just so we can stay consistent with that. So at time equals 14, yes, it's increasing. So 10:30 p.m. because the function is increasing at t equals 14. So listen, you don't need this lesson I just did right now. Well, I don't want to say you don't need it, but I went over a bunch of examples with you. This is a tough lesson. These are tough questions. I wanted to give you, a little bit more instruction with it. I want you to see it gone over. Hopefully you struggled through these. Hopefully you got them right. But if you didn't and you spent time on it, I wanted you to, have them gone over for you. So hopefully it was helpful. And listen, these are hard questions. I don't want you to feel super, super discouraged if you're really struggling with it. If you're a strong student, hopefully after seeing this, it makes sense to you. If you're struggling, try and get the basics down. Hopefully this made sense as I went over it. But, this is definitely a challenging question. That's it. The question I gave you in the quiz is not, again, it's still a challenging lesson, but it's not, I did not give you the hardest question that I could have given you based on that. I gave you a relatively simple one for this lesson. And any questions, reach out to me and remind. We have one more lesson in this unit, and then we're done with Algebra 2 material. Again, any questions, reach out to me and remind, and have a great day.